Hi, my name is Brill, and I attend Bill Crothers Secondary School. This is my Math CCT for advanced functions. What is advanced functions, you may ask? Advanced functions is the mathematical study of any polynomial, rational, logarithmic, and trigonomic functions concerning the rate of change and applying these concepts and skills. My question concerns lesson 5.2, exploring quotients of polynomial functions, page 262, number 3, A, B, and C. My question says, write an equation for irrational functions with the properties as given. Whole at x equals 1. B says vertical asymptote anywhere and a horizontal asymptote along the x-axis. C finally says whole at x equals -2 and a vertical asymptote along the x-axis.
Let's start with what a rational function really is and some basic rules that pertain to this mathematical element. As defined, a rational function is a division of two polynomial functions. This means you have an expanded or simplified polynomial in both the numerator and the denominator. Some basic rules that relate to this particular subject come in a wide variety. The first one is when both the denominator and numerator contain a common factor. In this case, it was x minus 1, as you can see from the graph and the function. This created a whole at x equals 1. The second rule states, if you take a restriction on the bottom, this will be your vertical asymptote. The third and final rule is a rational function has a horizontal asymptote when the degree of the numerator is less than or equal to the degree of the denominator. For example, looking at f of x equals 2x over x plus 1, the degree of the numerator is equal to the denominator. Both are degree 1. Extending further with this concept, this graph both has a vertical asymptote and a horizontal asymptote. Let me ask the viewers a question. How can this be? That's right. The unexplained vertical asymptote is from the restriction on the bottom. If you got that right away, give yourself a pat on the back. When looking at application with the rational function, thermodynamics states resistance over voltage equals current. In this case, I have 100t plus 10 over 0.3 to t squared is my function for this application. When looking at thermodynamics, volume equals concentration, K constant, T is temperature, and over P is pressure. Both are found in the science world and are most commonly used in chemistry.
Looking at part A to my question, it wants a whole at x equals 1. When looking back to our rules, a whole is created when a common factor on both the numerator and the denominator are displayed. When looking at the first example I decided to do, it's easy to see that x minus 1 is a common factor, therefore creating a whole at x equals 1. When looking at the second example of x minus 1 over x squared plus 3x minus 4, it is hard to see that there is a common factor on both the numerator and the denominator, but simply factoring out will give you x minus 1 over x plus 4 times x minus 1. This gives you a common factor of x minus 1 on both the numerator and the denominator, therefore giving you a whole at x equals 1. Both graphs will finally have a whole at x equals 1, depending on what they look like given the circumstance. Or part B says vertical asymptote anywhere and a horizontal asymptote along the x-axis. Let's talk about the horizontal asymptote first. The rule about horizontal asymptote says the degree of the numerator must be less or equal to the degree of the denominator. So I started with putting a degree 2 on the bottom and a degree 1 on the top. The degree 2 being x squared and the degree 1 just being 1. This made a horizontal asymptote along the x-axis. Finally, when looking at vertical asymptotes, this is a restriction on the denominator. In the question it says it could be anything. Since I already had the x squared, I subtracted a 4. And when simplified, you get a vertical asymptote at y equals 2. This is a simplified mass for the vertical asymptote, and here is the graph of the function. When looking at part C in my question, it asks for a whole at x equals -2 and a vertical asymptote at x equals 1. This is a most complicated question, but we will take it slow and walk through it together. The first thing I addressed was the whole at x equals -2. The whole was accounted for by the common factor in the numerator and the denominator of x plus 2, as you can see in the dotted green lines. This causes a whole at x equals -2, as you can see in the graph. When looking at the vertical asymptote at x equals 1, this is the restriction in the denominator. The restriction in the denominator is x cannot equal 1. When looking at the graph, this causes a vertical asymptote at x equals 1. Thank you for listening to my CCT and have a very Merry Christmas.